Yes, this video we would like to honor Lindsay Ream, who has a birthday today. Happy birthday, Lindsay. Bailey says happy birthday. Tyler says happy birthday. And Anna. And that's it. Nobody else cares. I do, Lindsay. And Alex says happy birthday. I would just like to say for the record, though, that when we celebrated Sam's birthday, it was even more fun than yours. Okay, all right. Here we go. Ooh, she doesn't like me now. All right. So, secant times secant minus cosine. Here's what we're doing today, okay? So, when you see that, I don't see anything squared. And what we learned yesterday is if you look on this sheet, this helpful sheet that I put together for you, that you should try to put in your brain. As you're looking at this sheet, you want to try to find something that's squared, because you see if you got something that's squared, there's a lot of stuff you can insert, right? So, watch. If I distribute this through, sometimes you do, sometimes you don't. I can't tell you one way to do it. I'm just giving you options. So some of these problems you're going to try once, you're going to work it through, then you're going to realize, hey, that didn't work out. And so you're going to try it again in a different way. You got to be willing to try the problem more than once. Okay? So this will test your resiliency as a mathematician. Yeah, your foresight. So secant times secant is going to be secant squared of theta. Minus, what's the relationship between secant and cosine? They hate each other, yes. They are reciprocals. And if you multiply two reciprocals, you get 1. So now we have secant squared of theta minus 1. Now, some people could see that right away when they started out. You know, they quick distributed it, they saw what they got, and so they see that it's going to get tangent squared. So yes, that kind of foresight is important in this type of problem. What? That's your final answer. Any questions? Going once? Twice? What? Yes, excellent. Shh. And his question is this. If we don't have something squared, should we distribute? Generally speaking, yeah. If you have something that's already squared, a lot of times you like to factor. Now that doesn't always, it isn't always the case, but that's kind of a general idea that you would like to operate under. So again, I can't give you one way to solve this. That's why I gave you a sheet that has like 40 examples on it. Do you understand that? That way, you know, I can't give you a process. I could just give you approaches. So like this one, what do you want to do here? Yeah, even though I do have a squared, I'm going to distribute, because one thing you should notice is if I take sine times sine, that will give a sine squared, which we want. But then if I take sine times this, sine times a cosecant, those have what relationship? Reciprocal, so they will cancel and leave you with 1. So what's sine times sine? Sine squared of theta. If I take sine times cosecant cosine squared, I get just cosine squared of theta. And sine squared plus cosine squared is equal to 1. It's right on your sheet, problem number 5. Now, again, I heard somebody say, it was Kaylee Drescher. She said, I don't want to have to look at the sheet. I just want to know it all. And I said, well, great. You can know it all. You just have to know where this comes from. And I showed them this. They thought this was really cool. Sine is like sine is y over r squared. Cosine is x over r squared. And that's equal to 1. Why? Because then you have y squared over r squared plus x squared over r squared is equal to 1. Multiply both sides by r squared, and you get x squared plus y squared is equal to r squared, which is just your circle formula, or the Pythagorean theorem. So sine squared plus cosine squared is just a modification of something that we've always done, the Pythagorean theorem, and your equation for your circle. If you see the connectedness, you never forget it, because you know exactly where it came from. Can you remember that? Some of you can, some of you can't. If you can remember those type of things, then you don't need the sheet. If you can't, you need the sheet. All right. E, what do you want to do? Yep. FOIL it. 1 times 1. 1 times cosine. Cosine of theta. Negative cosine times 1. Negative cosine theta. And negative cosine theta times cosine theta is minus cosine squared of theta. So you end up with the cosines in the middle canceling. And we've got 1 minus cosine squared of theta, which somebody back there said. Back, Kelly had this on her test today. Yeah. You got that one? Do you see how I got this? See how I got that? Look at your sheet. Look at number 5. Sine squared plus cosine squared equals 1, right? So follow that over to the right side, and you'll have a formula there that says 1 minus cosine squared is sine squared then. Yeah. How about F? I'll do it with you. Tangent squared of theta minus secant of theta tangent of theta plus secant of theta tangent of theta minus secant squared of theta. What happens? Secant of theta tangent of theta, the positive and negative cancel. I'm left with tangent squared theta minus secant squared of theta. Huh. What to do, what to do, what to do. It's not 1. It's -1. Why is it -1? Isn't secant squared? No, secant squared is 1 plus tangent squared, right? So tangent squared minus 1 plus tangent squared. See how I substituted that in? Secant squared is the same as 1 plus tangent squared. Number what? 6 on your list? No, it says secant squared minus tangent squared is 1. Yeah, I'll show you. But does everybody see how I got this? There's more than one way to do the problem. Do you see how I got this? Distribute your subtraction sign through. Tangent squared of theta minus 1 minus tangent squared of theta. So they cancel, leaving you with -1, right? -1 is the result. Now, some of you guys are looking at your sheet and you're seeing this. Secant squared of theta minus tangent squared of theta is equal to 1. But that's not the same as this. Yeah, if you would take this and multiply it through by -1, then you would get the same as up above. So you could see instead of a +1 for an answer, you have a -1 as an answer. See that? So I haven't manipulated every formula to give you every possible result. I've just taken the chief ones and allowed you to work through there. What do you think of that? Casey's angry about this stuff. Casey, you're going to have to settle down. Yep. You got another sheet, too. That one's got like 50 formulas. Generally, people don't like that one as much. They like this one, but the other one, it's not organized very well. Organize it yourself. Your own. All right. 2 secant of theta minus 2, 2 secant of theta plus 2. Anytime you have conjugates are when they're the same. You just have a plus and a minus. You notice that the middle is always going away, right? So we could just multiply the front and the back. So we got 4 secant squared of theta, and we're going to have minus 4. Everybody good? What to do, what to do, what to do. Very good. Let's take out the 4. 4 times secant. There, you guys have foresight. What's secant squared minus 1? Good. 4 tangent squared of theta. Push-ups for your brain, remember? I don't know. All right. Well, all right. Okay, so like this one, some people would scratch their head and be like, okay, well, what happens now? Well, again, no. Some people might want to factor something out, but that really won't help you. You'll end up with tangent plus cotangent, which is absolutely nothing special. Okay? So then we're left to kind of wonder, well, maybe we should rewrite in terms of sine and cosine. And in this situation works out. And the reason why I see it's going to work out is, again, creating a square somewhere is important. And cotangent is cosine over sine. So cosine over sine times cosine, that will give me a cosine squared in the numerator, right? Oh, that's good foresight. Look at this foresight. Cosine times tangent. Tangent is sine over cosine, right? So that cosine will cancel with the denominator. Oh, so seeing those type of relationships quickly help you see what kind of approach might work out better than another. So we have cosine of theta over 1 times sine of theta over cosine of theta plus, and then for cotangent, we would have cosine of theta over sine of theta times cosine of theta over 1. And if you notice, the cosines, again, they cancel. On the right side, we end up with the cosine squared in the numerator. But over on the left-hand side, if you notice, we just have sine over 1, right? Well, if we want to add those fractions together, we need to have what? Common denominators. What is the denominator going to be on the right? Sine of theta. So I need to multiply the top and bottom by sine of theta. So I'm going to kind of add a step in here, sine of theta, top and bottom. And if we multiply, sine of theta times sine of theta is sine squared of theta. Oh, I got another squared. Well, that's pretty nice. I got cosine times cosine, which is cosine squared of theta. Whoa! That's beautiful. Do you see it? Sine squared plus cosine squared is 1. What's 1 over sine of theta? Cosecant of theta. Yeah. Booyah. I bet we could incorporate some trigonometry into pole vaulting. I bet we could. Any questions on that one? Enough of me doing problems. Why don't you guys try I and J on your own? And I copied this from a worksheet, so I didn't quite format everything together. The point is, are they different? I, J, 11, and 12, you know, they don't have to go in the right order or even be numbered in the same type of system, so we're okay. I want you to try I and J. I is the harder one. J is the easier one. And it's very similar to the problem we just did. And you guys could go ahead, post your answer on the board, whoever gets it first, and we'll all clap for you. If you make a mistake, that's okay too. That's okay. We all make mistakes. I make mistakes on the board every day, don't I? And you guys, thank you for reminding me, Casey. That's so nice of you. Good job. Let's try the last two. 11, what do you want to do? What do you want to do for 11? Let's factor out a cosine squared. I thought to factor out a cosine squared because if I did factor out cosine squared, I get a 1 plus cotangent squared. So I saw that as soon as I looked at the problem. And when I saw that, I knew that there was something I could substitute for 1 plus cotangent squared. Cosecant squared. So I have cosine squared. Whoop. Cosine squared of theta times cosecant squared of theta. Now I rewrote it as cosine squared theta over 1 times Yep, so I get cosine squared of theta over sine squared of theta, which is equal to cotangent squared of theta. As I told second hour too, I won't be giving you the easy problems on the test. I'll be giving you some of the middle level and the harder ones. I would say this is a middle level problem. No. No. And again, so my job is not to just give you stuff you can do, but to try to push you a little bit. You're absolutely right. I can't agree with you more, but that's the nature of the work. Yeah, that's a very good point, Hannah. A lot of people on this test last year, they went down, some road, some approach, and they tried really hard, and they made some work on their paper, and but ultimately they were incorrect. So it's like you can maybe give them 1 out of 3 or 1.5 out of 3. You try to find some maybe 2 out of 3 if they really develop something, but ultimately that's where you're at. So how about 12? Do you see ahead here? I do want to distribute or factor out a sine. Either way, you're going to get some stuff to cancel because cosecant times sine is 1. They are reciprocals of one another. And you don't always. So I get 1 minus cosine squared of theta. So everybody see how I got that? The cosecant times the sine makes 1, and cosecant times the other sine makes 1. No, here, I'll write this one out. There's too many blanks, so watch this. Do you see that? Okay, so what I did is I rewrote cosecant to be 1 over sine. Okay, and now I wrote them all together. Now do you see that this piece right here goes to 1? Do you see that the sines cancel there and leaves you with just cosine squared? Very good. And 1 minus cosine squared is sine squared. Oh boy. Forgot about that one. Yeah, I've got a meeting that I will not go to. Okay, so I should probably let somebody know, shouldn't I? Okay, so here's what we need to do. We need to have an assignment. So, Coach Wayne, do you hear the groaning? And I just handed back an assignment or a test. We're out of 48 points. I think that the average score on that test was 46 or 47. So yeah, and it's almost like, you know, I haven't they learned to trust me that if I give them something, it will result in good things. I only have good intentions for you people. Only have good intentions. So, 7.1, page 540, numbers 1 through 22, not 12 or 21. This assignment will destroy you if you don't get on it right away. I'm not kidding. If you wait to do this for 3 days, you're going to come back, you'll be like, I don't remember anything we did. Well, congratulations. You shouldn't. Okay? If you're normal, you'll walk away in 3 days if you don't practice it. So you got two responsibilities. Number one, if you want to convert to long-term memory, you must put this on the working table tonight. Then you must sleep. And if you don't do those things, you won't retain the information. Unless you're an alien and you're a mutant that operates differently from the rest of the world. The plus or minus infinity, this is called heresy or blasphemy by Ben Jones. Do not take mathematical advice from Ben Jones. That's all I have to say. Good luck, everybody.